All right, the last topic, vectors and motions in 2D world. The 2D world is like a plane, so it actually had the angle. This topic is basically just moving with angle. So for example, let me give you an example. A car is, this is a ball with is moving upward with a constant speed of, no, with an initial speed of 30 meters per second. It's a fast ball with the angle like 30 degrees above the ground. What? Let me ask you, what is the vertical components of the ball, and what is the horizontal components of the ball? In this topic, resolve a vector into components is very important. Let me use 3 stars. It's very important. Using trig. We don't like angles, so we love trigs. No, we also don't like trigs. Trig ratios. Using trig ratios. So for this one, the vertical component is just v naught times sine 30 degrees. It's 15 meters per second. For horizontally, it's v naught times cosine 30 degrees. It is 15 times square root of 3 meters per second. Or it can ask you in the opposite way, like this. If an object is moving with an x component of 10 meters per second, no, with 9 meters per second, and has a move with a horizontal component of 12 meters per second, what is the speed? What is the velocity of the object? The first thing we need to do is the sum of vector. The second thing is using Pythagorean theorem. So how can we like calculate the sum of vectors in this situation? So this is 12 meters per second horizontally. Let's transition. Let's move this 9 meters per second vector to this position, because vectors can move in left and right parallelly. So the sum of the vector is just like this, because it's moving this way first and then going that way. This is the sum of the vector. This is perpendicular. So the velocity is just square root of 9 squared plus 12 squared is equal to 15 meters per second. Let me say this again. Let me write this again. Resolve a vector into components is very important. Let me give you another example. All right, another ball is being kicked. Right after it got kicked, it has initial speed of, let's say, 40 meters per second with an angle of 45 degrees above the ground. It's asking you how long it will stop. No, how long it will come to stop. Vertically. So, first of all, right after they got kicked, the only force that acts on the ball is a gravitational force, which means it is doing free fall. This is also very important. You have to remember. This is also a very, very classical like conceptual sentence you will see, you will use when you're doing the test. Due to free fall and subject to gravitational acceleration, I would just use g. This is gravitational acceleration. Its speed. No, I will actually use velocity. If it's going upward, its velocity going upward. If it's going upward, will decrease. Will decrease. However, if its velocity is going downward, the speed will increasing. This is speed decreasing. So for this one, the ball has an initial speed of what, 40 meters per second. Has an angle of 45 degrees above the ground. So let's resolve the vector into components first. The vertical component is 40 times sine 45 degrees, which is equals to 20 times square root of 2 is close to 28.2, 28.3 actually. The horizontal component is 40 times cosine 45 degrees. It's also 28.3. Let's look at the free body diagram. There are no horizontal components that will affect ball's motion, which means the motion horizontally of the ball will never change, which means that means the ball will stays with this speed, with this 28.3 meters per second velocity all the time until it hits the ground. So we don't need to care about it. Also, another reason we don't need to care about it is asking you how long it will come to stop vertically. So basically, this question asks you when will your velocity vertically, just vertically, is equal to 0. So now we can see the importance of resolve vectors into components. The vertical component is 28.3 meters per second. It's equal to v. And then your acceleration is negative 9.8 meters per second squared, because it's equal to g, because it's just gravitational acceleration. So then we can use the formula of v is equal to v naught plus ad. Oh wait, actually the 28.3 meters per second is your initial speed, because yes, the final speed is asking when will the v vertical reach to a stop. Your final speed is when it comes to stop, which is 0. So let's plug in numbers. 0 is equal to 28.3 meters per second minus 9.8 times t. T is equal to 28.3 over 9.8. Is close to, I don't have a calculator beside me, so I would just say like 2.86, yeah, around that. So this is the answer. So from this question, we can see the importance of resolve a vector into components. Also, in the future problems you will meet, remember to resolve vectors into components. It will surprise you and it will help you solve a problem much quicker.